Hello, geometry students. Today we are going to cover theorems involving triangles. And majority of them involve writing a proportion to solve. So the first one we're going to take a look at, you can notice over here in the margin it says side splitter. So this is the side splitter theorem. It says if a line is parallel to one side of a triangle and intersects the other two sides, it divides those two sides proportionally. So in this picture over here on the left, we have a side, if a line is parallel, so DE, notice, is parallel to BC, it's parallel to one side of a triangle, and notice it intersects the other two sides. D intersects AB, and E intersects AC. So again, it fit the first criteria. If a line is parallel to one side of a triangle and it intersects the other two sides, it divides those sides proportionally. So if you look at the left side of the picture, notice D split AB into two pieces. We've got AD and DB. And on the other side, E split segment AC into two pieces, AE and EC. So again, they are proportional. So if you look over here, AD to DB, top to bottom, equals AE to EC, top to bottom. Okay, so again, it's going to divide them proportionally. So again, we have a proportion, and we've been practicing solving those recently. So if we do an example that applies the side splitter theorem, okay? So again, the directions say to solve for x. So again, notice in this picture, we have a line that is parallel to one side of a triangle, and it intersects the other two sides. It intersects this side here and this side here. So again, it divides them proportionally. So I'm gonna do like right over left. So I'm gonna do 6 over x plus 7 equals 4 over 10. Because again, these two are part of one side, these two are part of the other side. Now, just like we did previously, you know, if you simplify, it might make your mental math a little bit easier on you. So for example, 4 over 10, both divisible by 2. So this could reduce to 2/5. And again, now if we do cross products, we're going to have 2 times x plus 7. The other direction, 6 times 5 is 30. Next, we're going to distribute our 2. So 2 times x is 2x. 2 times 7 is 14. And again, that equals 30. My next step is I'm going to subtract 14 from each side. So if I'm moving on up here again, I'm going to have 2x equals 30 minus 14 is 16. And then to finish solving, if I divide both sides by 2, x is going to be 8. So again, when you have a line that's parallel to one side of a triangle and it intersects the other two sides, it's going to divide those two sides proportionally. So hence we have a proportion, we can write one and then solve. Our next theorem about triangles, you can see it over here on the left, is mid-segment. Now for future reference, some textbooks call it midline. It means the same thing. Okay, so a mid-segment is a segment connecting the midpoint of two sides of a triangle. So let's just look at that concept first. So notice D is the midpoint of AB. We can see that by showing those two segments are congruent. They have tick marks. And E is the midpoint of segment EC. Again, notice you can see that with the tick marks. So again, DE would be a mid-segment here. Now notice, it says the mid-segment is parallel to the third side. So that means DE and BC, like I wrote over here, are parallel. And it's half as long as the third side. So the length of DE is half of whatever BC is. So let's just pick a number. So let's say you picked the number, let's pretend BC is 14. DE is going to be half of that. So half of 14 is 7. So now I have an example down here below. It says find segment VX. So VX is this one here. So if you think about it again, VX is half, not my bad, let's try that again. RS is my mid-segment, it's half of VX. So think about it, if RS is 10, half of what number gives you 10? Hopefully you're going to tell me that Vx is 20. If you know the mid segment and you want to work backwards to find the other one, you would double it. 10 times 2 is 20. And if you double check it, what's half of 20? 10. Okay, we have two more theorems to talk about. Both of these theorems involve angle bisector. So let's take a look at the top one first. It says if a point lies in the bisector of an angle, so in this picture, ray DB bisects angle ABC. So notice it splits it into two congruent angles. So again, if this point D is on the bisector, then the point is equidistant from the side. So if you think of the word equidistant, equal distant, okay? So that means that the length from D to A is the same as D to C. So again, any point on this bisector, so if I put one here and I drew a segment, this length would be congruent to that one. Again, it's equidistant to the two sides. My cut point could be out here somewhere. This segment is congruent to this segment. Again, it's equidistant to the two sides. So if I look at my example, it says the figure shows a triangle with its three angle bisectors intersecting at point P. So this point P here is equidistant to the sides. So if PB is 10, so again, if I'm looking at it in terms of this angle here, if the distance to this side is 10, the distance from P to C to this side is also going to be 10. So the length of PC is 10. Okay, so for our final theorem for today, again about triangles and angle bisectors, this one is back to a proportion again. It says if a ray bisects an angle of a triangle, so notice in the picture, BD bisects the angle because it shows these two angles are congruent. Then the ray divides the opposite side into two segments. So notice the opposite side here was AC. It now got split into two pieces, AD and DC. So again, it says it divides the opposite sides into two segments that are proportional to the other two sides. So the other two sides of the triangle were AB and BC. So again, if you look at my proportion over here on the right, AD to DC is equivalent to AB to BC. Notice I put AD on the top, then out of these two sides, I'm going to put the one that's closest to it, that would be AB on top as well. So AD to DC equals AB to BC. So if I look at my example down here at the bottom, I want to again notice the directions say to solve for x. So again, when you bisect an angle, it divides the opposite side, so this side of 9, into two pieces. So we got to figure what those pieces are right now. So if this piece is 3, I need to know what this one is. Well, again, if it tells me the whole side is 9, 9 minus 3 is 6. So again, it split this opposite side into two pieces. So if we look at it, 3 over 6. Again, I don't want to put 3 over 9. I need to have these two pieces. So 3 over 6. Since I put 3 on top, which of these two sides is closer to 3? Hopefully you're going to tell me it's x. So then I'm going to have x over the other side is 8. So again, 3 over 6 equals x over 8. I could have done, if I wanted, 6 over 3, and then which side is closer to the 6, the 8 or the x? Then I could have done 8 over x. You're going to get the same result. So again, what I would do first is reduce. 3 over 6 reduces to 1/2. And now if I do cross products, I'm going to have 2x equals 8. And if I divide both sides by 2, x is going to be 4. Okay, back to this problem. Again, I could have reduced it. 2 over 1. Again, I'd get 2x equals 8. So x is 4, either way you look at it. Okay, as long as you are consistent with your proportion, there's actually a variety of ways you could write it. So again, today we had 4 theorems that involve triangles. Today, you have a worksheet to practice it. And as always, if you have any questions, please let me know. Bye.